Okay, so this week we are talking about analytic geometry, which is basically looking at geometry from an algebra standpoint. So I was looking for memes, and this one really made me laugh just because it said sleeping with ovens since 1619. And I was like, well, what does this even mean? So I start cracking up. And then it says he didn't sleep in an oven, but he did invent analytic geometry while sleeping in a room with the oven. I don't know. I have to look into this. I'm like, was there an oven instead of a heater? I don't know what this means, but it made me laugh. So that's why I decided to pick it. So I'll just skip the outline. So we have only 4 sections this week, which is a nice break from last week where there were 10. So we're skipping from 4 and 5 now to chapter 10. And so 10.1 is lines. That should be nothing new. That should basically be all kind of straightforward. They do kind of talk about finding the distance from a point and a line, which is something new, something different that you haven't done. 10.2 is talking about parabolas, which again is something that should be reviewed because those are just quadratic equations. We're just looking at it from a different standpoint. So you're going to see the equation in a different light. And then 10.3 and 10.4, those are new things. Those are ellipses and hyperbolas. So those are basically new in addition to the existing things that you have. So you've got your discussion, your application assignment, the journal, and the self-assessment. So let's talk about the discussion this week. This is another one where you have to do research, which means you need to include all of your links. So this week you are researching one of the conic curves. So you're going to be researching into a parabola, an ellipse, or a hyperbola. And so you're going to share a little bit about the history and where these things are used. That's where do these things come up in real life? That's the most important part because we always want to try to connect what we're learning to real life. You will find that the history of all 3 of these things are they're very much in common. They're all pretty much created by the same person. There are some other people involved, so if you can find some information on the other people involved, that's cool. And then when you talk about your applications, try to give a demonstration of it, maybe a picture or the equation or something to kind of make it connect to the math more. And it does specify you should be using at least 2 reputable sources in your post. So you would need to have at least 2 different sources. So I'm going to be looking to make sure that you're talking about the history of the conic. You're giving us an application, and I'm going to be making sure that you have those 2 references at a minimum. And you want to explain this in your words, so I don't want to see any plagiarism, any direct quotes. So if you have a source and you don't understand what it says, then don't use that source. That means you need to find a different source, because if you don't understand the source, then just copying that information, it doesn't mean anything because it doesn't demonstrate that you've learned anything. So you want to make sure that whatever your sources are sources that you understood so that you can summarize what you learned. So the assignment this week, once again, we have 5 questions. And you want to make sure you're asking all the questions asked. I'm still seeing, I just started grading the week 6, and I see a lot of people missed the comparison part in problem 1. So you need to make sure you go back and you answer everything. Explain your work. I'm seeing a lot of math, but no explanation of where the numbers are coming from. It's like the numbers are just being pulled out of nowhere. So if you're going to pull numbers out of nowhere, if you did some calculations, you need to explain how you came up with those. If you're creating new equations, explain what these equations are. Because there's especially in the week 6 on problem 1, I told everybody in my last intro, I was like, you got to explain because there's lots of ways to do this, and I'm not seeing that. I'm just seeing a lot of math and then no explanation of, well, these numbers are just popping out of nowhere. What does this mean? So make sure you're explaining your work. Make sure you're reading the problems carefully, because problems 1 and 4, usually people misread those problems, and then that's where they lose points because they're not actually giving what was asked for, or they're labeling points wrong, and so then they're working with the wrong information. So be very careful when you're looking at those particular problems. And then problem 5, there's a similar example from the textbook, but it doesn't really go into a good explanation. So I took that same example from the textbook and I've worked it out in more steps and with more explanation. You can find that in the supplemental material. So there is a resource on that. And Jeff, let's see, simply type out what is going on in your head as you're doing it. Yes, that is really helpful. So for example, for this week 6 assignment that you guys all turned in, since I'm grading it right now, I see a lot of people that are giving the diameter, but they're not telling me that they're finding the diameter, or they're saying, oh, I have 8 inches times 2 pi, and they're not explaining where the 8 inches came from. That is 2 times the radius. I'm seeing people just saying, oh, it's a 1-to-2 ratio, but they're not explaining where that came up with. How did they come up with that? I'm just seeing, 14 inches times 4 pi, but they're not giving the equation that's coming from. They're not explaining where the 4 pi came from. Like, there's no explanations. And so when you're going in your head, you're thinking, I need to explain, like when I did this problem, I said, okay, our pedal has 1 revolution per 1 second. And so the pedal has, let's see, it moves, if it's 1 revolution, that's 2 pi. So it moves 2 pi in 1 second. And then I said, okay, it's got 4 inches. So then that's 8 inches in 1 second, like explaining that in words. Yeah, it's definitely worth getting to work on that, because I left a comment on somebody's paper that I could follow it, but that's only because I knew what they were supposed to be doing. And if anybody else looked at it, they would have no idea what was going on. So you don't want to just put down your math for my benefit. You want to write your work in a way so that anybody can understand what is going on. And sometimes that means you need to write sentences to kind of explain your next steps. And a lot of that's the thinking that's going on in your brain that you're not writing down. And so I'm like explaining, okay, this is the circumference, this is the diameter, that sort of thing. Exactly, Jeff. Type it out as if you're teaching someone else how to do it. That's exactly what you should be doing, because you need to prove to me that you know what you're doing. And the best way to do that is to pretend you're the teacher and the expert. And so write it as if you're teaching somebody else. That's a good way. I'm going to have to remember that and explain that for next time I teach this class from the very beginning. Be like, this is how you should be showing work. Some of them, if it's a formula, that's pretty straightforward. But when there's a lot of moving parts, that's really when you need to show some work. So as far as the week 7 assignment, problem 2 does have multiple steps where you need to do that. Problem 3 and 4 are also the same. There's lots of moving parts for those, as well as problem 5. So because you have to find lots of intermediate steps in between. So for this assignment, you're definitely going to have to say, okay, I found this. Now I need to find this, and like do it step by step by step. But I'm glad that you guys are giving me your thoughts on this as well. Because if you can explain it, that means it gives you an idea that you know what's going on. So that's the assignment. Your reflection journal. You guys are still doing great on that, so I don't really have any. And that's another good thing about the reflection journal is like you can, even some of the thinking that you're doing in your head, you can type that up in your reflection journal, and then when you write your assignment, you can kind of make it more concise in a way. Your self-assessment this week is 12 questions on the week 7 material. And then so the schedule this week, let me zoom in. So there are 4 sections. So I've got it split up a section a day. And then because there's these extra links, I put those for Monday and Tuesday, but you can do those wherever. Like the ones that are on, you can kind of match it up with the right section. So if you want to look at those links the same time you're reading that section, that's fine. But there is some free time if you want some extra days. So if you need to redo some assignments to get a better grade, you can use that time to do so. I did pick out some review problems from each, from the chapter 10 review, so that you can at least have some practice problems on the sections so that to help you study for the self-assessment. And then I've also mapped out each question on the assignment with which section it goes with. So that way you can do the right section with the right, the right problems. So you're not confusing your parabolas with your ellipses and your hyperbolas and that sort of thing. So that's about it for the introduction. This analytic geometry stuff, this shows up again in calculus. And because a lot of times in calculus, you're taking different shapes and then you're rotating them and you're looking at things over 3D objects. And a lot of those 3D objects are sort of created based off of the conic sections. When they explain what the conic sections are, they actually go into details how it takes the 3D object. And then depending on how you slice it, that gets you a conic section. And so you're kind of reversing that in a way when you start getting into calculus. So that's where this is going to connect you going further when you're going into the next class. You probably won't see it until Calc 2, though. It usually is not a Calc 1 topic. So do you guys have any questions for me? All right. Well, thank you guys so much for joining and also sharing your own tips on how to show your work on assignments. That's very helpful. I'm definitely going to probably use some of those tips in my feedback as I continue grading. So I appreciate that. Looking ahead at the calendar, so our next live is scheduled on Sunday at 1 p.m. That's going to be on section 10.4 hyperbolas, because that's usually a rough section. That last question on the assignment that I have the example on, that's on hyperbolas, and that one's usually a struggle for people as well. So I'm going to do some more problems on that and some similar problems so you can see how it all kind of fits together. So hopefully I'll see you guys at 1 p.m. on Sunday. And then we'll be moving on to week 8, so we're almost there. And then you guys will be all set for calculus. So hopefully you're not too nervous about calculus. I think calculus is a lot of fun, so hopefully you guys will enjoy calculus as much as pre-calc, because I know a lot of people are like, oh, this stuff's pretty fun, so hopefully that continues. All right, well, thank you very much for joining. I'm going to pop off and get this thing all saved up and posted for everyone else, so thank you guys, and I will see you on Sunday.